Okay, now what is the set of positive powers of 3? Let's list the elements of the set, maybe write this set out in a couple of ways. Well, actually, first, let's just say we could write this as x such that x is a positive power of 3. We could write the set that x such that x equals, what do we mean by positive power of 3? 3 to the p, where p is an integer greater than 0. And actually, I think maybe we need to be a little more specific. Let's say the positive integer powers of 3, because there's certainly non-integer powers, the 1/2 power, and any other positive number you might choose. 3 can be raised to any power. But what we really mean is integer powers. So we could write it this way, or we could list the set, which would consist of 3 to the 1, 3 to the 2nd, 3 to the 3rd, and so on. Now this is an infinite set. Its cardinality is, as we'll see in the last section, infinite, and there's a specific infinite cardinality there, and we'll talk about that. But for right now, this is how you would list the set. Or we could just list 3, 9, 27, and so on. Now the pattern here is actually clearer than the pattern here. You might have to think for a minute to think that 3 to the 3rd power is 27, whereas it's very clear that we're doing succeeding integer powers of 3 in this case. But either way of writing it out would be correct. Now this is an infinite set because there's no end to the positive integer powers. What about this set? -10, -9. Actually, let's make it -10, -8, -6, ending at 0. Is this a finite or an infinite set? Now, a lot of people will say that this is a finite set because it's bounded below and above. It's got a smallest number and a largest number. But of course, there's an infinite number of real numbers between -10 and 0, so you can't just say it's a finite set because it's got bounds on it. You have to say it's a finite set maybe because it's a bounded set of integers. Okay, so it's finite because it's a bounded, meaning there's something below which it can't go and something above which it can't go, because it's bounded, but that doesn't by itself guarantee it. But now that you say these are integers, we can certainly say that that set has to be bounded, because that set has to be finite. You can't bound a set of integers and have an infinite set of integers between two bounds.